Okay, so good morning, everyone. Today, we'll start with a new topic, which is about the theory of heat. Okay, now if you recall our discussion about temperature, last time I mentioned that if an object has a certain temperature that is different from the temperature of its surroundings, what happens? When the object, for example, a cup of coffee, of course, you place it on a table, is hot, and the temperature of the surrounding air is, of course, colder than the temperature of the coffee, what happens is that the temperature of the coffee will always decrease. The temperature of the coffee always decreases until it becomes in thermal equilibrium with its surroundings. Bakit nangyayari yan?
Sir, dahil po yung surrounding air niya po is cold, so nagkakaroon po ng process of transfer of thermal energy po. So dahil po mas mainit po yung sa coffee, nag-transfer po yung init ng coffee sa air. And yun po, until mag-spread out and magkaroon po ng thermal equilibrium.
Okay. So you are telling us that ang natatransfer ay yung init. Tama ba yun?
Yes po.
Pero may sinabi ka kanina sa akin eh. Ang sinabi mo is nagkakaroon ng transfer of thermal energy. Let me quote you.
Okay.
Okay. So you are telling me that thermal energy and init are the same.
Hindi po. Sorry po.
Diba?
Nasa isip ko po kasi iba
Isipin mo yun, no?
ng mainit temperature.
Okay. So, may mainit na kape at may malamig na hangin na nakapalibot sa kanya. Eventually, habang tumatagal ang kape ay lumalamig. No? Can you please explain why? Again, can you repeat your explanation?
Because the thermal energy from the coffee transfers to the surrounding air.
Okay. So according to you, there is a transfer of thermal energy that is taking place from the hot coffee into the surrounding air. Is that what you're telling?
Yes po.
Yes. Okay. Yes. Tama ba yun, guys? Do you think what Ernest said is correct? Ha?
Opo.
Yes. Actually, tama iyon. Nagkakaroon ng transfer ng enerhiya mula sa kapeng mainit papunta doon sa kanyang surroundings. Habang nagtatransfer ng energy, bumababa ang temperatura ng kape hanggang wala na siyang matransfer. Bakit? Kasi nagkaroon na ng thermal equilibrium. Nagkakaunawaan po ba? Yes. And actually, the transfer of energy that is taking place from the hot coffee to its surrounding air is what we call heat. Yun ang heat. So itatanong mo sa akin, Sir, ano ang heat? Ang baho naman yan, Sir. Maanghit. Okay, so the actual transfer of energy that is taking place from a hotter object to its surroundings, which is at a colder temperature, is what we call heat. Naiintindihan po ba? Now, that brings us to the topic of heat. Again, based on my discussion, who can define heat? No? Based on my discussion na ginawa dun sa previous slide. Go, Queenie. What is heat?
Heat po yung actual transfer of thermal energy from hot to cold between two bodies po.
Okay, so bakit nagkakaroon ng heat?
Kasi po hindi po sila same temperature. Tapos
Yes.
yung in order to have thermal equilibrium po, tsaka po nag-o-occur yung heat.
Okay, can you please state it in one complete sentence? In English?
In order for the two objects to have thermal equilibrium, heat, which is the actual transfer of thermal energy from hot to cold between two bodies, happens po.
You describe or state the definition of heat, no? How do you define? You define in a manner that you mention the word being defined first. Heat is defined as Chorbachenes eklabu. Okay? Go.
Heat is defined as the actual transfer of thermal energy from hot to cold between two bodies in order to have thermal equilibrium.
In order to have thermal... Actually, I'd like you to replace the last phrase, in order to have thermal equilibrium. No? Bakit nagkakaroon ng transfer of energy?
In order for them to be in thermal equilibrium po.
Okay. In order for them to be in why? Bakit? Hindi ba sila in thermal equilibrium with each other? Di ba?
Hindi pa po.
Bakit? Bakit hindi sila in thermal equilibrium?
Kasi po, they do not have the same temperature.
Yun ang sabihin mo sa definition. Okay? Kasi yun ang cause. Di ba? Yun ang cause. Let's go.
Heat is defined as the actual transfer of thermal energy from hot to cold between two bodies that is not in the same temperature. Nalilito po kasi.
Okay. Okay. She is trying her best. No? She's trying her best and that is good enough for me. Okay? Thank you, Queenie. That is correct. No? Tama naman yung sinasabi. Kaso nga lang, of course, we need to refine the statement so that mas maganda yung definition. Okay? So, thank you, Queenie. So, once again, kagaya ng nabanggit ko kanina, whenever there is a transfer, no, or whenever two bodies having different temperatures are placed in thermal contact with each other, there will always be a transfer of energy between them until thermal equilibrium is reached. And this transfer of energy is what we call heat. Okay? This transfer of energy is what we call heat. So now, how do we define heat? We define it as the transfer of energy, no, across a boundary of a system due to temperature difference. Okay? So this is how we define heat. It is the transfer of energy. Of course, there is a boundary. Across the boundary of a system due to temperature difference. You have to mention this in the definition. Why? Because this is the reason why heat occurs. Because there is a temperature difference. No? And how is the energy being transferred? No, from the system to the surroundings, or from the surroundings to the system. No, that doesn't depend on the system or on the surroundings, but it depends on the temperature. Okay? Which one is hotter and which one is colder? Naiintindihan po ba? So it's always transferred from the object at a higher temperature to the object or to the system at a lower temperature. Naiintindihan po ba yan?
Yes po.
So
Yes,
tandaan na, the only requirement is temperature difference. Okay? Again, who would like to repeat the definition of heat? Okay. Go, Adlin.
We define heat as the transfer of energy across the boundary of system due to a temperature difference.
Yes, due to temperature difference. Okay? That is correct. So when we say heat transfer, ano palang ibig sabihin nun? Technically, it's redundant. Bakit? Because the word heat already means transfer of energy. So pag sinabi natin na heat transfer, medyo redundant na yun. Pero alam niyo yun, the word heat transfer is so entrenched, no? Kumbaga parang nakatatak na sa ating bokabularyo, even among scientists. Okay? And due to popular usage, the terms heat flow, no, heat transfer have been generally accepted without any misunderstanding. Why? Because they are usually interpreted properly rather than being taken literally. Okay? So that is what I'm trying to say. Technically speaking, the word heat means a transfer of energy. Okay? So when we say heat transfer, we are being redundant, no? Because we are transferring the transfer of energy. Di ba? Okay. But of course, when we speak of heat transfer and heat flow, we do not interpret or take these words literally, but rather we interpret them properly so that there will not be any misunderstanding. Nagkakaunawaan po ba?
Yes po,
Okay.
sir.
So, ayun, nabanggit ko lang sa inyo na redundant pala yun. Pero, yun nga, sabi ko naman sa inyo, we do not take things literally. Rather, we interpret them properly. No, ano pang isang kagayang, ang isang halimbawa niyan, no? Sa ME, redundant sila sa heat transfer. Pero sa ECE at sa electrical engineering, meron ding redundant, no? Kapag sinabi ng teacher, current flow, mali yun. Why? Because the word current already means flowing electric charges. So when you say current flow, you're actually being redundant. But again, just like what I have said, when we speak of current flow, we do not take these words literally. Rather, we interpret them properly. Akala natin sa ME lang may redundant, yun pala sa ACE din, ano, at saka sa electrical engineering. Okay? Now, again, no, yung paglipat ng energy ha, yung mismong pag-transfer ng energy, yun ang mismong heat. Nakakaunawaan po ba? Okay. So, ibig sabihin pala niyan, heat is an energy in transition. Yes, no? Hindi mo pwedeng ma-transfer ang heat. You cannot transfer heat. You transfer thermal energy. As a matter of fact, it's the thermal energy which is being transferred. Okay? But again, in our common language, we refer to that energy being transferred as heat. Ayan, pinayagan ko na rin. Ano? The amount of energy transferred in this manner is also referred to as heat. That's why the word heat transfer is also acceptable. Nakakaunawaan po ba? Hello,
Yes
guys.
po.
Yes po.
Again, heat cannot be transferred, technically speaking, because rather of transferring heat, you transfer thermal energy. The transfer of thermal energy is what we call heat. No? But again, when we speak of heat, no, when we say heat transfer, the word heat there is the energy transferred in that process. Okay? However, there is no such thing as amount of heat in a body. Okay? A body cannot possess heat. What can a body possess is thermal energy. And this thermal energy is associated with the kinetic energy of the molecules and atoms that make up that body. The higher their kinetic energies, the higher is the thermal energy. Okay? And that is related to temperature. No? Di ba sinabi natin na ang temperature ay measure ng average kinetic energy ng mga atoms at molecules? Yes. So therefore, temperature can be described as a measure of the thermal energy? Yes. Okay, the higher the thermal energy of a body, the higher is its temperature. Nakakaunawaan po ba? And when this thermal energy is being transferred, because there is a temperature difference, that is what we call heat. Okay, remember that the driving force in order for us to have heat is temperature difference, no? And the larger the temperature difference, the higher is the heat or the rate of heat transfer. Okay, now, I want you to consider this hot coffee. Okay? So, yung mga hindi pa nag-almusal dyan, ito ang mainit na kape. Okay? Shit. No? Na-trigger ka kasi para sa iyo, yung amoy ng kape ay talagang may dalang pleasure ba? Diba? Ang sarap kaya ng amoy ng kape. Masarap ang amoy ng kape, pero ako ay hindi masyadong pala kape kasi madaling manakit ang tiyan ko sa kape. Kaya more on tsaa ang aking iniinom kaysa kape. Okay. So mainit ang kape, it's hot, just like me. Diba? The coffee is hot. Its temperature is 80 degrees Celsius. And of course, there is a surrounding air. We can assume that the coffee and the mug are in thermal equilibrium. So the temperature of this mug is the same as the temperature of the coffee. Okay? But they are hotter as compared to surrounding air. That's why there will be a transfer of energy, no, that will take place from the hot coffee into its colder environment until this coffee is now in thermal equilibrium with the surroundings. Now, that transfer of energy again is what we call heat. Di ba ang galing? Amazing grace. Now, imagine Sarah, no? Si Sarah ay nagbabalat ng patatas. Ang patatas ay mainit. Dahil mainit ang patatas, ito ay may taglay na mataas na thermal energy. So this baked potato is hot and a portion of its thermal energy, no, will be transferred into its surroundings, no? So these 2 kilojoules of thermal energy, as it is being transferred out of the system into the surroundings, that is what we refer to as heat. And therefore, we can only conclude that heat is energy in transition. So ngayon, sana ay gamitin nyo na ang word na heat properly. Kasi alam nyo na kung ano ang ibig sabihin ng heat. Okay? Now, again, I'd like you to define heat. Ulitin natin. Ano nga yung heat?
Heat is the transfer of energy across the boundary of a system due to temperature difference.
Yes, exactly. Due to temperature difference. Now, how do we measure heat? Because heat is a transfer of energy, then heat has the same unit as work and energy. In SI units, what is the unit of energy?
Hindi ko po sure ha, pero Joule ba yun? Charot.
Yes,
Ah,
that's correct. It's not joule, it's joule.
Joule. Ay, sorry,
Okay?
Joules.
It's joule. Yan, not joule, it's joule. Say it again.
Joules.
But not joule, it's joule.
Joule.
Ang arte-arte.
Arte
Okay.
po.
So this is the unit of heat, work, and energy in SI system. Now, aside from joule, there is another popular unit of heat, which is called a calorie. Okay, and I think most of you are familiar with calorie. Why? Because of course, when you are working out, when you are exercising, you want to burn calories. Para ikaw ay mamayat. Di ba yan ang sabi mo? Okay. So, what is the definition of calorie? Okay, we define calorie as the amount of heat that is required to raise the temperature of 1 gram of water from 14.5 to 15.5 degrees. Okay? So, I repeat, no? We define calorie as that amount of heat required to raise the temperature of how much? 1 gram of water, no? By how much? By 1 degree Celsius. But the 1 degree is specified, no? It's from 14.5 degrees to 15.5 degrees Celsius. Again, would like to define calorie?
Sir,
Okay, si Criselda. Go ahead, Criselda.
the calorie is the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius from 14.5 to 15.5 degrees Celsius.
Very good. Very eloquent. Very eloquent. Okay? Now, that is the definition of calorie. Another is, oh wait, the food calorie. No? Di ba yung ating mga pagkain, may label sila na calorie, calorie, calorie. Di ba? Okay. Yung food calorie kasi capital letters yun. No? The food calorie, which starts with capital letter C, is actually a kilocalorie. No? Kilocalorie which means that one food calorie na kilocalorie, ito yun, sulat ko na nga dito, no? 1 calorie is this, no? Pero yung 1 capital letter C calorie is the same as 1 kilocalorie. Naiintindihan po ba? Ito yung food calorie. It starts with capital letter C, no? And it's actually equal to 1 kilocalorie, meaning 1,000 calories. Naiintindihan? Now, in the English system of units, there is a corresponding unit called BTU, the British Thermal Unit. And the British Thermal Unit is defined as the amount of heat that is required to raise the temperature of 1 pound, no, of 1 pound of water from 63 degrees Fahrenheit to 64 degrees Fahrenheit. Okay, so the definition of BTU is somewhat similar to the definition of calorie. Pinalitan lang natin yung units, no? Yung 1 gram, ginawa natin 1 pound of water. At yung temperature ay, instead of 14.5 to 15.5, naging 63 to 64 degrees Fahrenheit. We should know how to convert calories and BTU and joule, no? How do we convert from one unit to another? So this is the conversion factor. 1 calorie is equal to 4.186 joules. I want you to memorize this. 1 BTU is 1055 joules, which is also equal to 252 calories, and is also equal to 778 foot-pounds. Okay? So these are the conversion factors which you need to memorize. Sa tatlong ito, alin ang may pinakamalaking magnitude? 1 joule, 1 calorie, or 1 BTU?
1 BTU po.
Yes. No? Of these three, 1 BTU has the highest magnitude. Okay? Now, let's talk about another important form of energy which is related to heat. Okay, this is what we call internal energy. Sir, what is internal energy? From the word internal, no, we are referring to the constituents of a certain material. For example, there is a material, a metallic material, and we are talking about its internal energy. Then we have to look at the constituent particles that make up that material. No? So we define internal energy as the sum of all the microscopic forms of energy of the constituent atoms and molecules of a system. So the internal energy strictly refers to the microscopic forms of energy of the constituent atoms and molecules. So they may include the following. First, the internal energy includes the kinetic energy of the random, translational, it could be rotational and vibrational motion of molecules. The molecules and the atoms that make up a system are always in motion. And how do they move? They move translationally, they move rotationally, they can rotate, and they vibrate. So all of this motion accounts for the internal energy of that system. Now, in addition to the kinetic energy, meron pang potential. Di ba? In addition to kinetic, may potential pa. The vibrational potential energy associated with forces between atoms in molecules. Okay? So there is vibrational potential energy and electric potential energy that is associated with forces between molecules. So all of these energies, no, which are microscopic in nature, these are the energies that make up the internal energy of a system. So these microscopic forms of energy again refers to the sum of all the kinetic and potential energies of the constituent atoms and molecules. However, the internal energy does not include the bulk, kinetic, or potential energy of the system. What do you mean by the word bulk here? Does not include the bulk, meaning that its potential energy as a whole, no? For example, an object has a potential energy because it is elevated from the ground. Gravitational potential energy. That is not included, no? Because that is the potential energy of the system itself. Okay? The bulk potential energy. And if an object moves, it acquires a velocity. So that kinetic energy is not included here. Why? Because again, this internal energy only involves microscopic forms of energy. Is this clear?
Yes po.
Eh ano naman ngayon, sir? Ba't mo dinidiscuss yan? Because internal energy is related to the temperature of a system. No? The higher the internal energy, the higher is that temperature. Nagkakaunawaan po ba?
Yes po.
Sir, may nabanggit ka pa kanina na ano? Thermal energy. Yun bang thermal energy at saka internal energy ay related? Actually, yes. No? Minsan, yung ibang mga references, ang tawag nila sa internal energy, tinatawag din nila na thermal energy. No? However, the distinction is that thermal energy only involves the kinetic energy of atoms and molecules. But internal energy also involves potential energy, not only the kinetic. So, we can think of internal energy as a larger set, no? A part of the internal energy is the thermal energy. Naiintindihan po ba?
Yes po, sir.
Yes po.
Tandaan ha, this internal energy is associated with the temperature of the system. Okay? Now, internal energy is an extensive property, meaning it depends on how much of the system are we talking about. Okay? Nakadepende siya kung gaano kadami. Ang kabaliktaran kasi ng extensive is intensive. Kapag ang property ay intensive, it doesn't depend on the amount of substance being considered. For example, temperature. The temperature of ice, when it is melting, does not depend on how much ice is present. Whether that is one ice cube or one block of ice, no? The melting temperature is the same. It's 0 degrees Celsius. Okay? So that property is intensive. But internal energy is extensive, no? So meaning that it depends on the amount of substance we're talking about. For example, a more massive object would have more internal energy than a less massive object provided that they have the same temperature. Naiintindihan po ba? Okay. And we cannot measure internal energy directly. So, what we can measure is the change in internal energy. Okay? So, we will talk about internal energy, more about internal energy when we reach the topic of the first law of thermodynamics. Okay? Now, I have a question. Is it possible to change the temperature of a system without the addition or the removal of heat? Do you think it's possible? Walang transfer of thermal energy in the form of heat. Posible bang magbago ang temperatura ng system? Is that possible? Yes or no? I'd like to start a poll. Okay, so the poll has been launched. You may now start answering. But now, yeah, there's no better high since you pushed my love aside. Charot. I'm out of my head. Baka yung iba mag-leave the meeting na kasi kumakanta ako. Okay, we're able to gather 36 votes. 37. Okay, end the poll. And show everyone the result. Ang ganda ng resulta. Tight yung laban. Kita niyo na ba ang resulta?
Yes
Bye.
po.
So,
Yes. It's a tie between the yes and the no. Pero alam mo yun, may limang nagsabi na it depends on the system. Mag-iingat ka sa mga ganyan, ha? Ito ang clue. Kapag may choice na, alam mo yung hindi siya black, hindi siya white, siya ay gray. Yun ay may napakaliit na chance na tumama. Maliit ang chance na tumama yung ganyan, ha? O, tip ko na yun sa inyo, tip. No? Kaya kailangan mamili ka, it's just a yes or a no. So, nagkataon tayo, bibigyan ko ng chance na mamili sa yes or no ang mga ito, yung bumoto ng 5. Okay? Sinong gustong lumipat ng bakod dun sa 5 yon? Okay, Ernest.
Sa yes po.
Yes ka. Si Queenie.
Yes din po.
Grabe, ang babaeng ito. Ang sagot pala, it depends. Nakakaloka.
Thanks.
Ngayon ay yes. How about the 3? So, lamang na ng 2. Si Dayan.
Yes daw po, sabi po ni Dayan.
Yes. Okay. Si Carlo. Anyway, panalo na. Panalo na ang yes. Kasi kung si Carlo man ay mag-no, dadalawa na sila. 3 na yung nag-yes. Diba? Okay. So, this time, nanalo ang yes. Now, what's the answer? Is it possible to change the temperature of a system without the addition or removal of the heat? Is it a yes or a no? Adlin, what do you want to say?
Sir, I believe po na yes. Nag-base po ako sa microscopic definition ng temperature which states na temperature is also related to the molecular kinetic energy of molecules that make up the material po.
Okay, ay kung yes, paano? Paano magbabago ang temperatura kung hindi mo lalagyan ng heat or hindi mo mababawasan ng heat? Diba? So if your answer is yes, then how? Do you have any idea? Actually, that is correct. The answer is yes. Okay? The answer is yes. But the question now is, how? How can you change the temperature without the addition or removal of heat? Sige nga. Sige nga. Okay, may tumataas ang kamay. Tumataas ang kamay ni Maika. Maika, go ahead, Maika.
May malang po ta, charot. Yes po sa akin kasi parang temperature is a measure of the average kinetic energy of the system po.
Yes,
Then,
actually, mag-move on ka na dun ha. Na-resolve na iyon. Yes talaga ang sagot. Ang itinatanong ko na ngayon, paano kaya? Paano magbabago ang temperatura kung hindi mo dadagdagan o babawasan ang heat? Diba? Tama yun. Yes.
Parang-
The right answer here is yes.
Tama.
But how?
ano po, thermodynamics states that the change of energy of a system is equal to the heat added to the system minus the work done by the system po.
That doesn't answer the question.
Ay, sorry.
That doesn't answer the question. How are you going to change
Oh.
the temperature
mali.
without the addition or removal of heat?
Charot lang pala.
It's okay, it's okay. Thank you for trying. Genald,
Try lang po. Ano po, by doing mechanical work po.
by doing mechanical work. By doing mechanical work. Eh kung
Nax.
ano yan, hindi ka naman mechanical. Ikaw ay electronics. Queenie, anong gusto mong
Repeat
sabihin,
daw po.
Queenie?
Sir, ano po, yes po, possible po na ma-change yung temperature of a system without the addition or removal of heat. Kasi po, the change in internal energy of a system is equal to the heat added to the system minus the work done by the system po.
So,
Tingnan mo.
nasa ang punchline. Hinihintay ko yung punchline.
Wait lang po.
Ginaya mo lang yung sinabi ni Micah eh. Ganun yung sinabi
Hindi
mo
po.
eh.
Hindi po.
Nakakaloki
po,
ka.
ano po ba, sir? Yung as in po, wala pong addition or removal, or hindi po natin sure kung addition or removal?
Walang addition.
As in wala
Without.
po.
Without. Balikan natin
Mali
si
po pala.
Hindi, okay lang yun. Okay lang yun. Okay lang. No worries, no worries. Balikan natin si Genald. Genald, na-curious ako dun sa sinabi mong mechanical work. Anong ibig mong sabihin sa mechanical work? Can you give me an example of a situation in which you are doing mechanical work to a system which will cause its temperature to increase?
Siguro po
Genald.
ano po, kapag po kunwari ay nagbubuhat po tayo ng mabibigat para pong gayon.
So halimbawa, may isang object. No, may isang object. Tama ba?
Yes po.
Okay. Kapag binuhat ko yung isang object, magbabago ang temperature niya. Ano iinit pag binuhat ko? Halimbawa, nagpabuhat ako sa iyo. Genald, buhatin mo ako. Init.
Ano po, para pong, kumbaga po meron pong naka-intertwine po yung mechanical energy natin dun sa sinabi niyo po kanina na internal energy po. Para pong meron pong tawag dito.
Anong tawag doon?
Kaugnayan po para pong gayon.
Ano kaugnayan?
Yung pong mechanical energy.
Yung mechanical energy, saan may kaugnayan?
Sa dun po sa inyong sinabing internal energy po.
Actually, wala. Kasi yung mechanical energy, yun ay kinetic at potential nung object as a whole. And di ba sinabi natin kanina, they are not included in the internal energy. Ano lang ang kasama? Yung kinetic at potential energy ng constituent molecules at atoms, no? Which are not in any way related to the mechanical energy of the system as a whole. So the mechanical energy is a different form of energy than the internal energy. Again, they are not related. Pero na-curious ako, sabi mo gagawa ng work. O halimbawa, tubig. Paano mo gagawa ng work ang tubig? Actually, Genald was right. No? You can actually do work on a system. No? And increase its temperature. That's the correct answer. Tama yun. No? Very good. No? I think Genald did some research, but it's okay. No? It's expected of you. Pag hindi mo alam ang sagot, mag-research ka. No? So kapag ka ang isang system, ginawan mo ng work, you did some form of mechanical work on it, its internal energy would increase. Why? Kasi ginawan mo siya ng work. No? Now, kapag nag-increase ang internal energy, remember that the internal energy is related to the temperature. When you do work on a system and its internal energy increased, then that is the reason why its temperature would also increase. Naiintindihan? Bakit? Kasi nga ang internal energy ay related sa temperature. So kung magbabago ang internal energy niya, kasi ginawan mo siya ng work, then magbabago rin ang kanyang temperatura. Nagkakaintindihan po ba?
Yes po.
Yes po.
So now let's get back to the cup of water. For example, sige, isang basong tubig na nakalagay sa lamesa, no? Anong gagawin mo para sa uminit? Gawan mo siya ng work. Paano? Haluin mo. Haluin mo ng haluin. Yung baso, yung tubig sa baso, siya ay iinit. Mag-i-increase ang kanyang temperatura. Yan ang nadiskubre noong 1840s ng isa sa mga pioneers ng thermodynamics na ang pangalan ay James Prescott Joule. Siya ang nakadiscover ng mechanical equivalent of heat. And as I have mentioned, Joule is one of the pioneers of thermodynamics. So Joule is a British physicist who lived from 1818 to 1889. Ilang taon siya? 71. 71 siya nung namatay siya. Now, Joule received some formal education in mathematics, philosophy, and chemistry from John Dalton. Mentor niyo pala si John Dalton? Bakit hindi kami naging makaklase nito? No? Si John Dalton naging prof ko rin, no? Sa PE. Kaya pala, hindi kami naging makaklase nitong si Joel. Bakit? Kasi siya ay naging estudyante ni Dalton sa chemistry. Ako naman, naging estudyante ni Dalton sa PE. Doon kami nagbabalibol. So although Dalton was partly his mentor, in large part, Joel is self-educated. Joule's research led to the establishment of the principle of the conservation of energy, and his study of the quantitative relationship among electrical, mechanical, chemical, mechatronics, instrumentation and control. Nilahat ko na. No. His quantitative relationship among electrical, mechanical, and chemical effects culminated in his announcement in 1843 of the amount of work which is equal to produce a unit of heat, which he called the mechanical equivalent of heat. Alam mo yon, para mabago mo ang temperatura ng isang bagay, no? Ano ang normal na ginagawa? You add energy or transfer energy into it in the form of heat. Iinit mo siya, 'di ba? Para mag-increase ang kanyang temperatura. Pero may na-discover si Joule, no, na pwede mo daw painitin ang isang bagay na hindi nagdadagdag ng heat. Instead, gagawaan mo siya ng work. Galing, no? 'Di ba? Na paano ito? Ito ang kanyang setup. Gumawa siya ng isang setup kung saan may container at yung container ay may lamang tubig. Now, yung tubig, nilagyan niya ng paddle. This paddle will be similar to a spoon that is stirring a glass of water. So consider that you have a glass of water and you have the spoon. If you stir it, that is the same thing that will happen here. So he has a container that has water on it, and there is a paddle which will continuously rotate, stirring the water. Now, as the water is being stirred, work is being done on it. So physics tells us that if this water is continuously stirred, you are doing work on it. And the amount of work came from something else, no? Saan ang galing yung work na ginawa mo doon sa water? Galing yan sa potential energy na nagbabago-bago. Ayan, no? Kapag ito tumaas, bumaba, tumaas, baba, taas, baba, yan, nagbabago ang kanyang potential energy. Okay? So, yung potential energy niya ay natatransform into work. At yung work na yon ang nagdadagdag saan? Sa internal energy ng water. Kaya pala sabi mo, sir, kanina, na kapag ginawan ko ng work, yung system, yung kanyang internal energy ay magbabago? Yes! Doing work on water would increase its internal energy. And as a consequence, pag tumaas ang kanyang internal energy, yan, an increase in thermal energy would result to a rise in temperature. Paano niya ito nalaman? Naglagay siya ng thermometer, no? At napansin niya, kapag ito palang tubig na ito ay continuously, iyong hinalo, inistir mo ng inistir, napansin niya na ang level ng thermometer ay tumataas, which indicates an increase in temperature. Nagkakaintindihan po ba? Okay. Ngayon, ano ang nalaman nitong si Joule? Na-discover niya na yung change in temperature ay proportional doon sa work na ginawa mo sa kanya. Okay? The change in temperature is directly proportional to the amount of work done. So we now know the relationship. If we do a huge amount of work, no? We increase the temperature significantly. So kung ka-quantify lang natin kung gaano karami yung work, pwede nating malaman yung change in temperature. Yes, actually, ang work na ito ay equal sa change in potential energy. Di ba yung gravitational potential energy niyan ay mgh? If you know, in Physics 1, you learned in Physics 1 that the change in potential energy is mgh. Okay, pero dalawa sila eh. Dalawa yung masses. No? So gawin ko na lang 2. 2 mgh. Okay? Is equal to the amount of work done. Okay? At itong work na ito, yan ang magiging dahilan ng pag-increase ng temperature ng system. As if dinagdagan mo ng heat. Para palang ganun ang nangyayari. Ginawan mo siya ng work. Nung ginawan mo siya ng work, as if nagdagdag ka ng heat. Kaya ano ang tawag? Ayan no, mechanical equivalent of heat. Mechanical in a sense that this work is purely mechanical in nature. Nung ginawan mo siya ng work, parang nagdagdag ka sa kanya ng heat. Kaya sinabi natin na mechanical equivalent of heat. Now, more specifically, halimbawa, ito nasa taas, no? Itong mass initially nandun sa taas. Pag yan ay bumaba, magkakaroon ng decrease yung kanyang potential energy, no? And the decrease in the mechanical energy is proportional to the product of the mass and water and the increase in thermal energy. Ito pala daw 2 mgh na iyan, yung 2 mgh ay proportional saan? Sa product ng mass at ng increase in temperature. Ayan. So kung yan ay isang relationship, may proportionality tayo dito eh. Proportionality sign. Kung yan ay gagawin nating equation, dapat meron tayong proportionality constant. No? At yun ang kanyang na-discover. No? So again, this is the amount of the change in potential energy, which we can thought of as heat. Okay? We can think of it rather. We can think of this change in potential energy as the heat. Bakit? Kasi nga yung work na ginawa mo sa kanya, no, yun ay katumbas ng heat na naging dahilan ng pagtaas ng kanyang temperatura. Okay? Now, kung yan ay proportional sa M multiplied by delta T, no, kung gagawa ako ng equation, dapat maglagay ako ng equal sign at mag-introduce ako ng proportionality constant at yun ang kanyang na-discover. Ang na-discover niya ay ang proportionality constant na may value na katumbas ng isang calorie. Na alam naman natin na yung isang calorie ay gaano karaming joule? 4.186 joule. Para bagang ganito, itong calorie ay related sa heat. At itong joule na ito related sa work. So yung ginawa mong work ay may katumbas na heat. Kaya mechanical equivalent of heat. Naiintindihan po ba?
Yes po.
Now, tanungin ko kayo, no, kung nare-recall nyo, ano nga yung definition ng 1 calorie?
Calorie po is the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius.
Yes, exactly. That is correct. So, yun ang nalaman ni Joel, no? Nalaman niya na kung siya ay may 1 gram ng tubig, no, na sample, kinakailangan niya yung gawan ng ganito karaming work para mag-increase ang kanyang temperature ng 1 Celsius degree. Nakakaunawaan po ba? Is this clear?
Yes po.
Okay, so if that is clear, let us solve a problem.